We are going to finish off our discussion of formulas in section 8.6 by talking about our distance, rate, and time formula. All right, so when we're calculating distance, our basic distance formula is going to be distance equals rate times time. Right? I mentioned in the previous example we don't need to worry about memorizing our temperature conversion formulas, which is true. We do want to make sure that we kind of take note and remember our distance formula. Distance equals rate times time. Right? When we're working through these, right? When we're finding distance, if we just shorten this to our letters, D equals R times T. Right? So when we're finding distance, we are going to multiply our rate and time. Now, if we were to rearrange this formula and we were to solve for rate or time, right? Instead of multiplying, if we want to reverse our process of multiplication, we divide. So if we are looking for rate or time, right, we're going to reverse our process and we're going to divide to get our answer. So multiplication, we always multiply. When we're finding rate or time, we're always going to divide. As we're going through these problems, we want to make sure that we are labeling our answers very, very carefully. Right? So for distance, some common different units of measurement or labels we could see. Miles. Right? We could see feet. We could see something like centimeters. Right? Meters. We have a bunch of different units of measurement for when we're dealing with whether we're dealing with feet and miles or centimeters, meters, something along those lines. But we do want to make sure that we are labeling our units very carefully for our distance. All right, for time, we could see labels such as hours. We could see labels such as minutes. Right? We could see labels such as seconds. Right? We could see days or years, something along those lines as well. Right? So hours, minutes, seconds are good examples of different units of measurement and labeling for time. For rate, right? Remember, rate is a ratio, right? So as we're thinking about this, right? Rate is a ratio. And when we're writing these, we're thinking about this as being a ratio of distance to time, right? And we're going to use the word per to show that ratio. So we could have something like miles per hour, right? We could have something along the lines of feet per minute, right? Or something like centimeters per second, right? These are not the only labels that are possible. This is just some examples, right? So when we're thinking about and we're labeling a rate, we want to make sure we label it correctly, and it's some sort of distance per some sort of amount of time. Okay, so we're going to go through this next example, and we are going to find our missing values. As we are going through and finding our missing values, we're going to be using these formulas that are up at the top. Right? Distance equals rate times time, we're going to multiply. If we're looking for rate or time, we're going to divide. Right, so for example, 3a. Right, our rate is 7 feet per minute. Our distance is 63 feet. Right? And so if we look at what we're missing, right, we are missing time. Right? So we are going to divide. Right? We are going to take our distance divided by our rate. When we're writing out our formulas and we're thinking about division, our distance is always going to come first, and then we're going to divide it by our other value. So our distance is 63 feet. So we're going to take 63 divided by 7. So 63 divided by 7 gives us 9. We do want to make sure we label this correctly. Right? This is a unit of time. If we look up to our problem, we see the word minute here. So we are going to write our final answer of 9 minutes. Right, for B, right, we have a distance of 48 centimeters and a time of 8 seconds. What we are missing here is our rate. So again, we're going to divide. Again, we start with our distance in our formula. So R is going to equal to D divided by T. So R is going to be 48 divided by 8. 48 divided by 8 gives us 6. Then we want to label our rate accordingly. Remember, we want to think about this as a ratio of distance to time. Our distance is centimeters. Our time is second. So we're going to write 6 centimeters per second for our unit of measurement for our rate here. All right, then for example C, right, our time is 4 hours. Our rate is 75 miles per hour. So distance equals rate times time. So our distance is going to be 75 times 4. This one we're going to need a little bit of scratch paper for. Right? So make sure as you're doing these, if you are doing division or multiplication that requires a little bit of work, we want to make sure we show all of our steps. Right? So I'm going to take 75 times 4. 4 times 5 is 20. 4 times 7 is 28, plus 2 is 30. So we get a distance of 300. Okay. And then as far as our units of measurement go, MPH stands for miles per hour. So we're going to take this M, and our distance is going to be 300 miles. Okay. So if we're looking for distance, we multiply. If we're looking for rate or time, we divide. And then we want to make sure we label accordingly. The other types of problems that we can run into still using our distance formula would be something that looks more like a story problem. So in example 4, we're going to go through 2 story problems, talk a little bit about how we can use our formulas to help set these up. When we're doing story problems, the thing I like to do is read through my problem and start by making a list. Right? So Steve drove to the University of Iowa in Iowa City for a Hawkeye football game. He traveled 216 miles in 3 hours. What was his average rate of speed? Right, so I'm going to start by listing out what we know. Right, we know Steve's distance, right, was 216 miles. Right, we know Steve's time was 3 hours. Right, so what we are looking for his average rate of speed. Right, so we're missing our R. Right, we're looking for rate. That tells us we want to divide. So rate is going to be distance divided by time. Right, so our rate is going to be 216 divided by 3. All right, so using the edge over here for some scratch paper, our 3 is going to go out front. Our 216 is going to go inside. 3 goes into 21 exactly 7 times. We subtract, we get 0. We bring down our 6. 3 is going to go into 6 twice. 2 times 3 is 6. We subtract, we get 0. We don't need to continue on into a decimal or fraction. So we have a nice rate of 72. Right, when we're labeling this, remember rate gets labeled in distance per time. So we're going to say miles per hour. Right, and feel free to use MPH as an abbreviation for miles per hour. All right, so for B, we're going to do the same thing. We're going to read through the problem, make a list of what we know, and then use that to solve the final problem. Laura is planning a vacation in Nashville. Google Maps says it's 476 miles from Chicago. If she averages a speed of 68 miles per hour, how long should the drive take her? All right, so our distance is 476 miles. Right, our rate is 68 miles per hour. Right, and what we're missing is the time. We want to know how long the drive should take her. Right, time again indicates division. So we're going to take our distance divided by our rate. So we are going to take our 476 and we are going to divide that by our rate of 68. All right, so this one is going to require some long division as well. 68 divided into 476. We can do some estimating here. We could think that 6 goes into 47, or 68 is close to 70, which is close to 490. So we can do some kind of estimating here. You can take and you can make a list of addition. So we're going to estimate that 68 goes into 476 about 7 times, right? Because if we rounded 68 to 70, right, 7 times 70 would be about 490. So we should hopefully be pretty close here. We're going to go ahead and multiply. 7 times 8 is 56. So the 6 goes down, the 5 goes up. 7 times 6 is 42, plus 5 is 47. So our estimation was correct. This works out perfectly. If your estimation is incorrect, that's fine. If it takes you a couple of tries to figure that out. If you do need to add a decimal point and a 0 to keep getting a nice answer, maybe we get 7.5 hours or something like that. Right? That is totally possible as an answer to some of these story problems as well. All right, so our time here is 7. Right? When we're looking at our rate, our MPH, the H stands for hours. So it should take Laura 7 hours to drive from Chicago to Nashville. So as you're going through this entire section, be conscious and aware of your formulas, which values are getting plugged in for which, what is the correct formula to be using. If you do have signs in some of these problems, not that it necessarily applies with the distance problems, right? And make sure as you're going through that you are practicing with your multiplication and your long division as well.